Good morning, everybody. Good evening, wherever you are in the world. Welcome to another edition of CGS Live. This is the VFX edition. Today, I think what I'm going to do is... last week someone made a suggestion about doing a tornado, or a twister, which I thought would be cool. Hey, Audrey! How's it going? Thanks for joining me. I hope you're well. Had a good weekend. Yeah, so I thought we'd do the twister tornado, talk about different ways that we could approach it, and maybe come up with a cool shot. Yeah, good. Thank you. I bought a caravan, a little one, like a teardrop caravan, which is cool. So I'm excited to start using that. Yeah. So what was I saying? Tornado. Yeah, I think there are a lot of really cool things that we can do with a tornado. Hell yeah, caravan life. That's right, van life. Hashtag van life. It needs a bit of work. It's a bit of a project, but yeah, it should be cool. It should be good. It's really small, just like a little trailer, basically, but it's kind of cool shape. So yeah, there's tons of cool things that we can do. You know, when you're looking at tornadoes, twisters, there's lots and lots of different effects going on that contribute to the whole effect. So, I mean, I don't have any reference up. Did you watch Birdemic, or did you watch the trailer? I'm not sure I've been able to sit through the entire thing. Sorry, I'm just drinking my peppermint tea. Yeah, I don't know if I've been able to sit through the whole thing. I think I watched a fair portion of it and skipped. You watched it entirely. That's great. It is just, I love it how they're trying to like get rid of the birds with coat hangers. I think they're like trying to swat eagles with coat hangers or something. That's one scene that I remember. Yeah, it's just, the animation is just incredible. It's just not to mention the acting. Yeah, Birdemic. Okay, what was the name of the other movie? The raptor one? That looked ridiculous. I'm definitely gonna have to watch that. Raptor Pasta or something. Preacher? No, I can't remember. You'll be able to tell me. They really did good effects, mate. Velocipasta, that's right. Oh man, I'm definitely going to have to watch that one. I'd love to work on a movie like that. It'd be great. It'd be so much fun. There's no pressure. Anything's going to look good. Be a lot of fun to work on those films, I think. Very, very tongue-in-cheek. Velocipasta, yes, I knew what you meant. They did good effects makeup. Oh, I'll have to have a look again. I think, yeah, people that do effects makeup are usually pretty good. Yeah, that's right. The bar is low and the expectations are low. So anything you do is like, wow, that's great. Cool, throw it in. Yeah, I'd love to. It'd be great. It'd be so much fun. So yeah, I'm just gonna start. I'll jump into Houdini and I'm just gonna start throwing together a little scene. Now, I think I might do this over a couple of weeks because, we've only got 2 hours. So, so I think what I'll do is just start simply today, and then I might look for some assets or something that we can add into this at some point. And, we can just flesh it out as we go. Now, when you're talking about doing tornadoes in 3D, there's a few different ways that you could approach it. You could kind of, you could start with a tornado kind of shape and model it up. So, the tube is good because it has both two end radiuses, so you can kind of create that funnel shape. So, I realize this is very simple, but you could start with a modeled shape and for instance turn it into a volume. So V2B from polygons maybe, and turn it into a fog volume. Maybe add some cloud noise to it, or some other procedural volume noise. If we put a light in the scene, you will see, you know, it's got some volume to it. It's very low resolution, so let's just have a look. Give it a bit more res. My computer's making all sorts of noises, so maybe that was too much. See if my camera freezes. I think I've worked out that if I push my computer too hard, this camera freezes. So I'll try not to do that today. So you know, you can see you can add some noise to it and create a little volume. So that's, you know, one way to approach it. And obviously you need to do a lot more to make it look nice, but and have it rotate as well. So, you know, if you put a transform down here and rotate it around, you know, let's just do $F. Oops. You can see, you know, you can get some rotation going, and that could be like the core of your tornado. And then we could add some other things around it. And we may do that just to have like a really nice thick core. The way I'm going to approach it today though is a little bit more dynamic, and I'm going to use particles probably to start with. So the idea that I have is kind of like to just use a line to guide my particles. And there's this really cool tool in Pops called Pop Curve Force. So I put down a pop network, and I'm just going to scatter some points on the ground on this grid here. Maybe a lot of points. Plug it in. Plug in my line into the second input, and I'm just going to animate this line a little bit. So I'm going to put transform down. And tornadoes, you know, they're pretty big and they move pretty, well, they move pretty quickly, but they move slow relative to their size. So we'll just have it translate pretty, you know, pretty kind of slowly across this plane. So set a keyframe, oops, set a keyframe at the start, keyframe at 120, and I'll just drag it across. So we get this kind of motion. And then in here, I'm going to set the source to all points. I'm just going to say $F less than 2, and that will just bring them in on the first frame, and then not continue to source them beyond that. And then I'm going to use that tool, the Pop Curve Force. I may have talked about this before, I can't remember in the streams, but set that to second context, and you can see now I have like a guide in here where my line is. And if I play this, you see they get sucked up where that line is. And there's a bit of rotation happening as well, which is cool. So that looks pretty cool, but you know, not exactly what we want. So you've got controls on here. So you've got radius, so you can change the radius, influence radius. And you've got follow scale, which is gonna, there's arrows here which determine the follow direction. So you can see follow scale is gonna be the strength that it gets sucked up like that. So you increase that and they'll get sucked up faster. So you can do lots of cool things with this effect, but we don't want it to get sucked up so much. We want it to orbit a lot, because that's the main kind of motion of these twisters, tornadoes, is rotation. So we want them to rotate a lot. This is probably moving a little bit too fast, so I'm going to slow this line down. I'm going to drag this keyframe out to 240. I might try and get a cow in here when I've got this working well. I might try and put a cow in and get it flying around. I can't remember whatever. You guys must have seen Twister, right? That's great. Let me just get the camera right in there. Get some dirt in your eye. I can't remember what else is flying around in that movie Twister from the 90s. I think there's like a truck or something, like a tanker that explodes. That would be cool. Definitely cows flying around. Let's see, what else are we going to do? So, can you feel the dryness? Is that a quote from something? So let's up the air resistance. So what air resistance does is like drag. and the more you increase it, the more it will stick inside the pop curve force. So you can see the speed of this is still maybe a little fast, but actually what I might do for starters is just turn this off so we can focus on the behavior without it. I'll start using it. Can you feel the dryness? It sounds like a catchphrase for some sort of, you know, product that dries things out, like talcum powder or something. Can you feel the dryness? Let's go suction scale. Let's increase that. So suction scale is going to pull it more towards the center. Now influence radius, I'm going to take that up quite a bit. And you've got down here, you've got these curves. Can you feel the dryness? Yeah. You've got these curves which control fall off. So you can control the way that these forces, follow, suction, orbit, work along the curve or from the center of the curve. A very bad shampoo ad. Yeah, that's right. So suction force fall off from curve would be, when it's far away from the curve, it would be 0. And then as it gets towards the center, it would be more. So you can kind of, you know, for instance, do something like that. And you'll see that you kind of get, I think it's that way. Let's try inverting it just to make sure. Ah, there we go. That's better. So see these ones at the edges are getting kind of nothing. And then as they go towards the center, they get more. So that's cool. That works well for what we want. And you can kind of shape these. That's pretty nice. And so you can do the same thing with like the orbit. So orbit force follow from curve, so that, yeah, this is kind of doing the same thing as the suction, where as it gets towards the center of the curve, it gets faster. And as it's further away, it gets slower. So you get this kind of gradual increasing of suction. So you could increase that, you know, sooner if you wanted to. Or you could have it inverse. So that it's orbiting more around here and then less towards the center. It's kind of interesting. Maybe not quite what you want. Or you could do something like this where it sort of, that way it doesn't completely fly out. You can create some really interesting shapes that way. So I think it's probably still better this way, but just, yeah, it's always good to see what different settings or inverting ramps will do for you. So that's kind of cool. Now, what else? We've got force follow. So this is the follow, again, the fall off from the curve. So far away is going to fall off, is going to fall upwards, travel upwards less than right in the center. So again, you know, you can invert that and it will kind of rise up more on the outer rather than the inner. So it kind of looks a bit weird, but it's always good just to test. All right, what else have we got? Let's see. Influence radius. Let's crank that up a little bit more. We'll really get that fall off happening. So we can take these kind of ramps down like this, so that we get a much more gradual kind of suction around there. Even, you know, the follow we could have like right just in the center. Something like that. Wow, it looks cool from the top. And you can always add extra forces in here. So, you know, if that isn't pushing it up enough, I could always add an extra force, which is rising this stuff upwards. Although, you can see there's a bit of an issue where it's rising everything up. So we need to create some sort of condition for that, which we can look at doing. Maybe I'll just try and get a bit more happening here. Oops, turn that off. So yeah, that's kind of working. Now we also have shaping here. So at the moment, this radius is the same along the length of the curve. You can see it's just like this capsule shape. But if I start manipulating this, you can see I can actually shape this so that, you know, maybe at the bottom it's wider and then at the top it's narrower. So it kind of shapes this as it goes up. It'll start to kind of taper in more, hopefully. We probably need to, you know, maybe let it run for even longer I might just give myself an extra bunch of frames and then we can see what happens. Yeah, it's not doing too much. Let's try the other way. See what happens. The speed of it's pretty slow, so it might just need to be a bit faster to actually see the result. And you can see that's so fine that it's not sucking anything up. So let's just change that a little bit. Maybe these fall-off settings that I've done are kind of countering that effect of the tapering as well. The suction is going to always try to suck it to the center anyway, so you know, maybe we turn that off. And we might see, yeah, you can kind of see more. It's following more closely that shape. So let's try increasing the follow. Maybe just having a little bit of suction scale. It's a little bit fiddly, I find, dialing this in. Like, it does take a while to sort of work out the settings. So it certainly can be, you know, it can be a bit of a challenge to get the right shape that you want. I definitely think what we had earlier with larger at the base is probably better. I don't know if this is really going to help us, this shaping at the moment. Yeah, I think the follow scale probably want it to be a bit lower. So what I'm going to have to do to kind of get really custom behavior is to, you know, maybe start doing some vex. So maybe I want the follow scale to kick in a bit later so that as these things, you know, get older, they start to rise more. So that at the start they rise, you know, a minimal amount, and then as they get older, they kind of, you know, they start to shoot up a little more. And that's what we can do in this pop force as well. So we could say, if we turn on vex, you know, we could, I don't think they have a drop down for n age, but what we could do is just grab, let's say, force. So we could say force dot y equals fit 0, 1 at n age. So that is for normalized age, which means it's a value between 0 and 1. And so when the age is lower, I'm going to say 0, and when the age is approaching its maximum life, I'm going to say force.y equals 1. So what we should see is, over time, these particles should rise more as they age, although still it's affecting these ones, because I guess they're aging as well. So we may need to do something like this. If length v at v is greater than, let's say, 0, then do this little line of code. So what that's going to do is check to see if these particles are actually moving, because if we take length v, it's going to be the magnitude of the speed. It looks like maybe we'll set it a little higher. Oh, doesn't seem to be working. Let's see. I'm just going to set that to 0 for now. I think that's why, because I had that set to 1, so it was just setting stuff to 1. So if I change this max value here to 10, let's see. Hopefully we'll see some effect happening. No, I might need to take that magnitude comparison down to 0. Yeah, there we go. So you can see now only the moving ones are rising up. It's still not quite working, but you can see as they get older, as they kind of continue, that force gets stronger and stronger. So it's kind of working. Let's go 0 to 2. We can actually take this out of a fit 0, 1 and set like what age we want to work with. These particles are actually living for 100 seconds as well, which makes it kind of a bit hard to work with. So I might just take that down. So we could say, instead of the fit 0, 1, which just takes the normalized age from 0 to 1, we could say like between 0.5 and 1. So that's like, this is only going to kick in from half their age. So once they get halfway through their age, this force is going to kick in. So before 0.5, it's going to be 0. So it's just going to clamp at everything below 0.5. It's just going to get this 0 value here. Then anything above 0.5 to 1 is going to increasingly get towards this value, which is going to be 1. So let's see what happens there. Hey Mohammed, how's it going? I can't remember who asked about the tornado last time. Was it you? Is that why you're saying thank you? If it was, I hope this is helpful. So yeah, it's kind of working, but it's also kind of not. So I'm thinking that's probably not the best way. Let's see what else. I guess I'll put the follow scale up a bit. And again, I could do this same kind of stuff in the follow scale. So I could use the expression in here. You can just click on pass through and you can see here, it just gives you all of the variables that you can use. So scale follow, selection scale. So we can just do like scale follow equals, and we could copy this same expression here, fit. So fit, and we could times equals as well, so that it's a multiplier on this value. So we could do fit and age between 0.5 and 1. And then what you'll see is that we get very little suction now at the start until these particles hit their midway point in their age, and then they'll start to rise more. There we go. So that's maybe what we want to do. Looks like our age is not long enough now though. So I might go 50. So you can see they're just spinning on the ground until they hit their halfway point. They'll start to slowly rise up, but because I just changed the life expectancy, their midpoint is now different. So you need to kind of work that out. You don't necessarily have to use the normalized age either. You could just use age and then maybe look at the geometry spreadsheet and see when these particles are kind of hitting what value of age. So you can see here, these are hitting 1.6 and keep going through. So, I mean, we could just take it between 0 and, I don't know, 10. Let's see what that does. And then we'll get like a gradual kind of rising over time. So we should see this just increase over time. Or we could take it down 0 to 3. And we'll just see it get a bit stronger. And maybe this 1 we can make like 3. So it multiplies it up by 3. So it'll end up being like 9 eventually. There you go. And we could start it. Yeah. Maybe it doesn't kick in until they reach 1. So they spin for a bit and then start rising. So this is probably a better way to go about controlling it rather than doing it in the force. Because the force is kind of affecting everything, but this one is only affecting stuff still, which is within this radius. Wow, there's some crazy stuff going on there, where it's kind of leaking outside of the radius. That's interesting. So what happens when it goes outside of the pop curve force is that it sort of just detaches and no longer gets those forces. It sort of inherits the velocity that they had, but they sort of no longer get affected. So, you know, perhaps increasing the radius, or just maybe if I take my taper off, that might help. Keep everything inside. Yeah, it's cool. It's not, you know, it's not quite there. I think, you know, our rotation obviously is not strong enough for a proper tornado. And this might not become the main part of the tornado. It may just be like an additional element. Can't write. I can't talk. It's all right. We're all good. So yeah, you know, I think even though this isn't quite what I imagined yet, I'm sure we'll kind of get there a bit more. There's a few more things that we need to do. But, you know, this could be an additional element. So, and I've got it really, really dense at the moment as well. So if you imagine taking that down and then you've got a much sparser amount of particles, even less than this, and you could use this to do some other debris or something like that. All right, so let's try and turn my real-time toggle on and see how fast this is actually going. So it's pretty slow. So let's look at our orbit scale. We could do the same thing. We could take this same fit. Yeah, get a cow in there for sure. What I'm thinking with the cow is that once we've got these points, we could actually stick a cow onto one of those points. Just a rigid cow. Just like a plastic cow in somebody's yard that's been picked up. So what am I going to do? 0 to 5, and I'm going to go 1 to 10 on this one. I think I might have. I'll have a look and see if I've got a cow we can chuck in. So what I'm hoping to see here is a little bit of increasing in... Oh, that's suction, actually. I meant to do that on orbit, but we'll leave that. So once you've kind of done this once, you can just copy this around. And, you know, and just kind of play with that range for each one of these. So now we should see this orbit just increasing in speed between 1, so it's times, so it's 1 times 10 at the start, and then it should be getting faster, although it looks like it went too fast and it actually spun it to the edges, and then it's no longer being applied. So we need to increase our suction, I think. I'll get rid of this out of suction and just actually I'll just comment this one out for a second and increase this. So it's a massive balancing act, which is why, you know, some people tend not to do this approach for tornadoes, because it is a real pain to dial it in. But like I said, we'll just explore some different kind of approaches. And I think this one will be useful for some things, but I think we just need to kind of dial in those settings. So here you go. You can see it's just getting faster and faster as those get older. So we can, let's go follow. I'm going to up the follow scale. So I'm going to start it at 1, go 5 times. Let's have a look at the global force. So we've got this force along length, and I just noticed that black there. You can kind of see this red, and then there's a black end here. This has a fall off where you can control the force along the length. So I'll probably just take that off so that there's no fall off at all, and it just is the same along the entire length of the curve. So it's kind of interactive. You can just play with these settings and they will kind of update as you're going. So you can see it getting faster and faster and faster as it reaches the top, but then it does kind of stop. So maybe, I mean, this is huge now, but maybe we do need to increase our line length as well. And our line is just straight at the moment, so obviously we're getting a straight kind of tube behavior. But if we were to, you know, change this a little bit, we could animate the points. So we can put a transform down here, and we've got 2 points on this line at the moment. So we've got 0 and 1 here. But if I was to move one of these points, so I'll pick 1, which is the top point, I can actually move. Is it working? Let's see. Oh, it doesn't seem to be. That doesn't seem to be working. Guess from group, set the points. There we go. So I can actually move that top point around, and I could do like a kind of sine wave or something in here. So sine $f will actually just get it kind of moving backwards and forwards. If I do sine $f times 10, that'll increase the amplitude. So I could get that kind of wobbling backwards and forwards, and then I could do that in a different axis as well, with maybe a different frequency. If I just do plus, I don't know, plus 50, that'll change the frequency of the sine wave, and now I get this kind of rotation. If I also multiply by a value, let's go 10, that will change the frequency. So it'll make this one faster frequency, and this one on the x-axis is slower. So we get this kind of, you know, non-uniform movement now. What else could we do? We could also move the 0 point. Now at the moment, if I put the same thing on them, they're going to move exactly the same. So if I change the frequency by adding a value, or even multiplying it to make it faster, it will change the way that that's moving. So you get this kind of, these 2 points that are sort of moving differently to each other. So let's change the frequency of this one. Just change these numbers around. And what you'll get is this kind of to and fro motion, which is kind of cool. Might be a bit crazy and fast for our tornado. We might get some really wacky stuff going on now, because if we're moving our curve around so much, it may not have enough time to kind of suck this stuff up. Also, we probably need to increase the size of our grid now to match that motion. So I maybe went a little bit crazy on the motion of that. Let's see. So you can see, you know, it's kind of leaving a lot of stuff behind, probably because it's moving around, you know, too fast. So we could slow that down, or now we might need to increase or balance out some of these settings. It's kind of cool though. You can start to see, like, you know, this isn't creating our main funnel at the moment, but it could be used for creating some other kind of interesting effect. We also need to add a source, because these are just like flying in the air now once they leave this. So we need to kind of add something to tell it to fall back down once it's in the air. Okay, yeah, I wasn't really sure what that first word was. Cute tiny, yeah, cute tiny tornado. Just the start of something big. So I think what we should do is slow this down, because it's too quick. And I'm just going to do this kind of, because I can't be bothered editing these expressions, I'm going to do this a different way, where actually I will edit these expressions to say $FF instead of $F, so that these values are actually float values rather than integers, because I'm going to put a time shift down. You're too excited, typing too quickly. I'm going to put a time shift down, and then I'm going to do $FF divided by, let's say 10. And this will actually slow this down to 1/10 of the speed. You can see by frame 500, I'm only up to frame 50 here. So by setting these to output float frame values, turning off integer frames, changing this to $FF as well, then I can kind of slow this right down and it doesn't step. So you can see if I do divided by 2, it's kind of half speed. So at 500, it's 250, and it will now be half as fast. I think half will still be too quick, but it might be a little better. Yeah, it's not too bad. So the other thing that we could do is try and get this line to be a bit more interesting as well. So I don't know what would happen if we put a third point in here. It may break what we have. Yeah, there we go. Now we've got like an elbow, which is kind of cool. So what's happening, because by adding an extra point, can already see the cowl. That's right. Just imagine it flying around, swinging past camera. So what happened when I added an extra point was that now we're moving this midpoint around, and the end point is staying static, which is actually kind of not too bad. So we've got this elbow kind of moving around, and then if we resample this curve, don't need that many points, but if we resample it like that and then smooth it, we could actually get you know, a nice kind of smooth motion. Kind of interesting curve shape. We could probably also convert this to a, I don't know, let's try it here, put a convert down and convert to a NURBS surface, or NURBS curve. Let's see, NURBS curve. There we go. So maybe we'll do that instead. That works well. Now we get a nice smooth kind of curve. All right, so let's divide this by 4. So it's quarter speed. We can try increasing the follow scale so it sucks up a little faster. It's a bit of a banana. So, but you can see I'm still getting this nice tube, which is cool. Like, I don't know what you call it, the funnel, I guess. If I turn the guide off, we can see it maybe a little more clearly. So, still getting that funnel preserved, which is, yeah, it's kind of nice. And this is just going to kind of dynamically go around and suck up anything that's in its path. So, let's increase our scatter so we can see. Don't know if that'll be too many. Maybe, oh, I've got relax on, which is really slow on a ton of points. They have that on by default on the scatter. But, so that's 1,000,000 points now. Let me just increase my RAM a little bit on the cache. Here we go. So, wow, that's interesting. Very kind of dense now. And there's some weird things happening here. So actually what I might do is put a ground plane down. And hopefully those won't bounce straight away. Yeah, they look alright. That'll just stop everything going below the ground and also hopefully create some interesting ground interaction as well. So we'll see what this looks like. Maybe a little bit slow with so many points, so I might just turn that down a tiny bit. That should be 500,000. Should be a bit faster. So what I'm thinking, you know, we could do with this, and I think I can probably go a bit less on the points. Got 100,000. So what we could do with this, now that we have it, is we could use it, you know, because ultimately we want that kind of volume, we want a cloud. So if I was to just create an attribute on here, I'm just going to merge out just the particles, so star, pop star, pop star. And then at density equals 1, and then volume rasterize attributes to create that as a volume. Now, what I'm going to do is only do the things that are moving. So in here, again, I could just do that same kind of expression I was doing before. If length v at v, so this measures the length of the vector or the magnitude of it. If it's greater than 0, actually, if it's less than 0.1, let's say. Oops, close that. Remove point. 0 for the first input at ptnum, because we want to remove anything that meets that condition. And there we go. So it's only going to show those points up when they start moving. And it will probably kill them when they stop moving as well, if they do stop. So there we go. And now we can rasterize density, because I don't want to rasterize everything that's sitting on the ground. That would be overkill. But now you can see we're getting a volume from this. So we've got our particle scale here we can change. Take that down. Voxel size is okay. And because we've got the light in there, we can see the form. So, you know, we can sort of see how that's looking. It's very kind of tubey at the moment, so we do need to kind of do something about that. But you can start to see it's, you know, it's starting to form, you know, this spinning mass of volume, which is kind of cool. I definitely want to make it a bit more kind of organic, and I've actually, yeah, there's something I just thought of that I've tried before, which kind of works quite cool in trying to change the shape after the particle simulation, because the pop curve force can be a real nightmare to control. So I'll have a look at that in a sec. We'll try something interesting. And we still need to work on what's happening with these particles after they leave the tube as well. We can't have them just sitting in the air. Although this expression, if we adjusted it slightly, it would cull those when they got below a certain. So if I made that threshold a little higher, you can see that they actually just get removed. So that could be one way of dealing with them. And then just to show you kind of, you know, what we could do with this sausage tornado, we could put it into a Pyro Solver to get some like additional motion on it. So I'm going to rasterize V as well, because these have, if you have a look at the info, these have velocity coming out of the particle sim. It's good to create a marker just to see what that actually looks like. Whoops, vector. So you can see we've got spinning velocities. That's cool. So let's rasterize V as well. And then when we plug that into a Pyro Solver, I just usually set the flames to 0, go to the sourcing tab. Just get rid of the things that we don't have. We don't have temperature at the moment, but I'll just leave it there. Set the scale to 0. We've got V and we've got density. Shape dissipation is really high, but let's just run it and see what happens. Okay, so you can see we've got this kind of smoky emission happening. And it's a bit too kind of smoky and like cigarette smoky, I guess. There's a lot of tendrils, which maybe you wouldn't have because of the scale. But we're getting some really nice kind of cool stuff happening here. So you can see if I was to merge this now with my source, I would get these two things where I have this kind of more solid, maybe like a genie coming out. Yeah, that's right. It's a bit more magical, definitely. So, you know, we've got this kind of more solid core and this sort of more wispy stuff flowing off it. And actually the dissipation doesn't work too bad for, yeah, for this effect. So let's just run it for a bit longer and see what happens when it gets sucked up more. Yeah, it works. It works kind of better than I imagined. I love the Pyro Solver, the SOP-based Pyro Solver for doing this stuff, or even just testing and kind of R&Ding effects where you're not really sure, you know, what you're doing. You're just trying to come up with interesting workflows and see what works and what doesn't. The SOP-based Pyro Solver is great. I didn't have to do anything really. I didn't even have to do the things that I did on it. I could have just hit play and it would have worked. So yeah, I think it's really, really cool for, you know, just plugging in and seeing what happens. And now we're getting like this combination of these two effects. So we've got our particles down here, and we've got our Pyro Sim. And if we, you know, run this for a long time, we'll see that kind of do the whole effect. It's going to take a while though, because Pyro is pretty slow. Now, one thing that I was going to think about doing was having some control over the shape of my tube here, post-sim. Doing things post-sim is great because it means that you don't have to necessarily get the result out of the sim, which can be difficult. And it means I can add a little bit of extra control after a slow step like a simulation, which involves caching to disk or writing to memory. So we've got our original curve here, and we've got our particle sim. So this should kind of sit, because we're using the pop curve force, that curve should sit in the center of our points there. So I'm going to do this in a VOP, just so it's easier to illustrate what's going on. What I'm going to do here is I've plugged in the curve, I haven't yet, I've plugged in the curve into the second input there. And let's just see how many points we have. We don't have many points on here, so I'm going to resample this curve. There we go, to have a lot of points. Because what I'm going to do is use these point locations on this curve to control the shape of this. Or I'm going to try and blend to those point locations. And if I just go like get attribute P off the second input and plug that into the P on the geometry VOP, I need to plug this into PT_num. You can see all those points just stick to the curve, but I don't necessarily want that. If I create a mix here, what I could do is mix between those two positions, but you'll see it kind of doesn't really work. It's sort of mixing them all to 0. What's happening there is because of the way that it works, it's matching up point numbers. So it's actually blending, the point numbers that match are blending towards that curve, but all the other ones that don't match, because this curve only has 261 points, whereas we have out of here 100,000 points. So 261 points find a match on that curve, and then the rest, the extra 900 and whatever, don't. And they just get mixed to nothing, to 0, right in the center. But what we can do when we have two inputs of different point numbers is use a point cloud. So we could use point cloud open to find the point cloud. Basically, we can just choose file into the second input. We're going to query the position channel, and then I'm going to use a point cloud filter to create like an average position. So the filter kind of does like a blur, but it creates an average. So it's going to give me the average position of the points from the second input, which is the curve. Now, if I plug that into the mix instead, let's see what we get. I might need to play with some of these settings. I need to plug P in here as the reference position. And we've got this search radius and number of points. I think this is going to work. I may be getting some things wrong here. Let's see. If I go forward a little bit, I might need to just make sure that this, yeah, it's points. That should be fine. I've probably got this wrong. It's been a while since I've done this. Let's make sure PC open. Let's increase the search radius. Oh, maybe I just plug this into P. Let's see. That's just blending to, oh, there we go. We're getting some here. Let's just increase this radius. If I go 10 and do 100. Oh, there we go. We can see they're all blending to it now, but that's not, that's not great. So what I could try and do is, let's try this. I'll put that mix in there. Ah, there we go. So now you can see I can actually mix them all. Oh, there's some crazy things going on because this radius is really high. But now you can see I can actually mix all of those points to the line. So that's something. Still needs work, but now we can mix all those points to the line positions. Whereas before, we could only mix the ones that match those point numbers. Now we need to do some other things. So we only want to mix these ones that are in the air. So again, we could use velocity to determine that, but we could also use age. So we've got the age in here and life. If we divide age by life, we get normalized age, the value between 0 and 1. If we output that through a ramp, just so we can visualize it, we can see that as color. So let's have a look here. Set that to infrared maybe. And All these have exactly the same age because they're all just being spawned at frame 1. So that's a bit of a problem. So age is actually not helpful, and that's maybe why it wasn't that helpful in the popnet as well. I didn't really consider that, but because I'm outputting all these points at the same time on frame 1 and then not emitting any more, age actually is kind of not that useful. I guess what I'll do, let me put this below the speed-based cull, and then perhaps it might be more useful. I don't know, maybe not. So I think, yeah, we'll just deal with the ones that are sort of actually moving. Maybe let's just change this a little bit, 0.1. Alright, so let's have a look at this mix again. So yeah, there we go. So what am I going to do? I'm going to, on here, on resample, I'm going to turn on the curve U attribute. Just going to give me an attribute which runs from one end to the other of this curve. If we visualize that on here with some color, we can say ramp from attribute curve U. Get my spelling right. I'll make sure my view flag's on there. Okay, there we go. So we can see black at the end is 0 and white at that end is 1. And we might be able to use that to create some sort of fall off of this effect, this mixing effect. So we could do, let's try, what are we going to do? Here, actually, what I'm going to do is transfer this onto the particles. I could try and use the point cloud again, but I feel like that might not work too well. So let's use the curve U here. And I'm actually going to first set curve U. So I'm going to say on the particles themselves, I'm going to say curve U equals 0. So then they have a default value of 0. And then when I transfer this, maybe I'll transfer color as well just so I can see it. So you can see those as they get higher along the curve, they're getting towards that white value. We're getting these ones which are white as well, which is weird. That should be curve U equals 0. Did I get that name wrong? No, float. Oh, I guess maybe that's just the color being transferred. Yeah, I don't know. We could check, create a marker just to make sure. Because we don't want these ones on the ground to be a value of 1 because that will throw things out. So we'll create curve U attribute. Oh, there we go. They're all 0. That's good. So we're just getting a weird white color on there for some reason. And now what we could do, because these points have this curve U, we could bind that in. Curve U. If I plug that straight into the bias, what you'll see is that, there we go. So as it goes up, we get them blending towards that line. I may have lost you along the way, but yeah, hopefully that kind of makes sense, sort of. So we're using this curve U, which is at the base of the line here, and at what value we're transferring here, the black you can see here. The value is 0 here, but as it goes up, it goes towards 1. And if you imagine... Well, thank you for hanging in there, Audrey. So what happens basically, this bias goes between 0 and 1. Our curve U goes between 0 and 1. So that at the base, the bias, the mix, is remaining to our original particle position. But as this curve U value increases up the line, it changes the bias value. So it gradually shifts to the point position, which is this one, which is all just in a line. I'm not viewing it, so you can't see it, which is all just compressed in a line. So as we get further up, it just gets towards, once that curve U value hits 1, it blends into that point. Now, the cool thing is we can actually remap this curve U value. Because it's between 0 and 1, we can put a ramp down. I'm just going to change this name because I've noticed that errors when you have multiple curves in now. And I'll put a ramp down again. Call this one shape ramp. Make it a spline ramp. Plug it in. And then Make that infrared again. So here's my shape ramp. Watch this. Whoa, cool. So now I can actually control the shape of my tornado via this ramp. And this is all post, so we get this awful uniform tube coming out of the sim. But now, if I really want, or the director asked me to change the shape or whatever, you know, wants a bit more width at the top, or, you know, a bit more tighter in the center, or whatever it might be, you can change it via this ramp. So there's probably, you know, multiple ways of doing this, but this is just kind of one way that I came up with. And it now gives me that ability to create more of that funnel shape that I want. And I wonder if I was to take these values here and fit them, instead of between 0 and 1, which the bias is expecting, if I feed this, I don't know if I feed this bias value a, negative. So if I'm pushing that bias to be larger in one or the next, hey David, how's it going? Thanks for joining me. So if I push that bias to be more in one direction, so by setting this value that's going into the bias to be, you know, -1, it's essentially like accentuating the position in one direction rather than the other. So if I set this one to be 2 as well, you'll see the sucked in part get so sucked in that it starts to cross over. So you can actually make this larger than it was as well by changing that bias value to be greater or less than, you know, 0 and 1. So that now, you know, my actual position is kind of around here, 0.5 probably, and the value was more close to my, there we go, more close to my original position. But then if I pull it down, it actually goes even more. So you can do that sort of stuff as well. You're getting a little bit of weird crisscrossing going on here. So that might be a product of doing this. Let's see. Oh, maybe not. Might just be like maybe one of these values or something. Maybe this here. It's a bit too strong. There we go. Oh, cool. You use the point cloud method to get some nice animating backs. Oh, that was the velocity stuff. That's great. Cool. I'm glad it worked for you. And it's a good idea to have some hero bats in there. You always want kind of, you know, a couple of choice moments that, you know, that work really well, because like anything with particles, it's really hard to control sort of very specific behavior. So it's always good to add some custom stuff in. That's great though. I'm glad it worked for you. And did you do that in Houdini, or did you take that stuff into Unreal? So yeah, here we go. Running it through the volume rasterizer. You can see now, like, having this control is way better than that kind of, you know, tube banana that we were getting before. And let's see, what can we do up here? And we can certainly go back and tweak some things in our original simulation. Like, it's not perfect by any means, but this just gives me this nice little control after the fact. Let's run it through the Pyro Solver. I can probably take this res down, actually. Point cloud in Houdini imported into UE4. Niagara has nice Houdini data interface. Cool, that's great. I'll have to try it one day. I know I keep saying that. Oh, well, one day. I don't know when. But yeah, very cool. I'm glad it worked for you. Well, you could create, you know, you could turn this into a velocity field as well. Take anything out of Pyro and turn it into a velocity field, and take it into UE4 as well. Yeah, okay. Is it a little bit buggy, or just kind of takes a bit to figure things out? All right, so let's have a look at this. This is not looking too bad. Let's have a look at our sim. So sim's giving us that. We've got this extra little point cloud in here. Oh, cool. Yeah, look, I mean, you know, I think it's definitely going to be a process. I've done tornadoes before. I don't know if I've done one in Houdini before, but I've definitely done them in 3ds Max. And there's lots of different ways of doing them, so I'm just kind of looking at some interesting ways. You can see some really cool spiraling happening here in the Pyro, and that's the velocities driving, you know, from the pop sim, driving that stuff upwards. So it's the same idea of the velocity grid, you know, driving things same thing that you did for your bats. It's that velocity field which is rotating, and that's spinning the Pyro up. So that's starting to look pretty cool. Yeah, like I mentioned at the start, you know, there's lots of like modeling ways that you could make them as well. You know, start with a tube, turn it into a volume, add some noise, animate it, and you've got a very basic sort of tornado. But this is just, you know, some random ideas and just some experimental stuff. Just seeing what we can get going. I think this is kind of cool though. I think our Pyro needs work. You know, the scale of those licks and tendrils are way too small scale for what the size of this is. So, you know, perhaps we should have some reference in here. If I put Tommy in, he's going to be actually quite large, I think, compared to this, because I haven't really made this correct scale, although he's pretty small. I'd probably scale him down a little more. There we go. Oh no. Look out, Tommy. So, you know, that's probably the scale, and maybe, like, it's probably even bigger than that, really, but that looks kind of cool when you put something in there. Well, it could have gone one of two ways. Could have been cool, or it could have been average. So yeah, you know, now we can see we have some scale reference, and we could chuck a house in there or something. Or actually, let's Audrey, it's time to bring out the cow. Let's see if I have one. I don't know if I do, but let's put an agent down. I've got a library, which I can highly recommend getting. It's called, yeah, that's right. Bring out the cow. Do I have one? I don't. It doesn't look like it. This is alphabetical. This library of animals is actually really cool. That's right. Bring out the cow. I can't do a Texan accent. I shouldn't even try. That's I apologize. Calnado. Oh, now you're talking. How about a sand mouse? I don't know. What have I got here that vaguely, a T-Rex? That could work. Raptor. Do Raptor Nado. Puppy. Puppy Nado. Maybe not. Piranhas. Yeah, this asset library is so cool. It's full of animals. It's called Truebone Zoo, and it's free, or you can do a donation as well. And it's just full of these animals. So, like, I guess, you know, a camel is kind of cow-like. Let's have a look. So, slow walk. And I love using these just for testing stuff, or, you know, and they're like kind of low res, but that's fine. They have textures, which is great. So, you know, we could pick him up and fly him around, or we could have a whole bunch of them. And the way, you know, one of the ways that you could do that, a tornado made of bulls. Well, let's see. Do we have a bull? I think I did see one there, didn't I? Oh, maybe not. Buffalo. No bull, no cow, no bull. Elephant. That could be cool as well. Let's have a look at elephant walk. Yeah, let's do an elephant. I think that would be fun. So buffalo is the closest, yeah. I think an elephant might be kind of cool. Yeah, it's quite large. So what we could do here, if we want to use the same points that we kind of used, although we don't necessarily have to, we could actually, yeah, turn this into a rigid body or something and use the same force. But we could actually use wireframe to bones. Oh, that's just W. Although I hold spacebar W, but it's actually just W. And that is only with FBX that I'm seeing that though. So yeah, it's not like some specific bone view that I'm doing. This is just with the agent. That's all I'm seeing there. Is the bones as wireframe. So what am I doing? I'm gonna grab some of these points before I make them into a volume. And at this point, I think what I want to do, actually they have ID here from the particle sim is actually generating an ID, so that is handy. So hopefully they are constant. So what I'm going to do is just, I don't know, let's pick some points based on ID. So what am I going to do? I'll just randomly, actually. I'll just do a threshold. So I'll just create a threshold of points. So I'm going to say if rand at ID is greater than channel threshold. So I'm creating a random value for each ID, comparing it to a channel, which I'll set the value in a moment. And then if it's greater than that value, I'm going to remove point. So 0, run over all point numbers at ptnum. Okay, and create that channel. Looks like I've got some errors. Oh, I'm missing a bracket. There we go. So here's my threshold channel. So basically what you'll see, if I go forward, what you will see is that as I decrease this, I get more or less points. So when the value is 1, hey, no worries, David. Thanks for joining me. Enjoy your dinner. So, oops. Wow, what happened there? So when the ID, the random value generates values between 0 and 1. So it is never going to generate a value that's greater than 1. So when this is at 1, this threshold value, it's not going to remove anything. But as you drop it down, there is a portion of these points which does have a random value which is greater than 0.8, for example. And you can see some of those points get removed. And as I drop it way down, like 0, all the random values are going to be over 0, basically. Occasionally you might get one that is 0, but most of them are going to be over 0. So they will get removed. But as you go up, there is going to be a portion of them that is getting values generated below 0.075. So you get a small amount left behind. So what I'm going to do is just get a very small amount of points, and I'm going to turn these into elephants. So I'm actually going to do this before the cull here. There we go. And these are going to be my elephant points. So copy to points. Target points to copy to. Geometry to copy. Hey, look at that. Whole bunch of elephants. Oh, pack an instance. Made them jumbo. Oh, what am I going to do? No, I guess that's okay. So maybe they're already packed. Yeah. Alright, let's have a look. Whoa! Okay, it's a stampede, that's right. Look at that. Beautiful. There's some flipping going on there because we don't really have any orientation attributes being driven. But what we do have is elephants being whipped up into the tornado. So, you know, this is amazing and ridiculous, but you can imagine, you know, that you could use this for a lot of, yeah, it's so rigid, and not even rotating as well, just staying completely upright and all facing the same direction, which is great. So we'll definitely fix that. But this could go straight into Birdemic, or it would have to be some other Demic, elephant based. What is it? What is an elephant? Is pachyderm? Maybe pachydermic. There we go. Next film. Look out for it. So yeah, we need to do some like spinning orientation attributes on here because this just is, you know, is not working. So we could just do like a random orientation. So attribute randomize, for example. Just going through the day as if it's normal. That's right. Wondering why they're in the air. So we could do an orient and randomize that. And that will, when we copy though, it will affect the ones on the ground as well, I think. Let's see. Attribute randomize, orient. It's a 4-dimensional. Is that setting? Oh, you know what? I think because these are packed, I think maybe that's why as well, that these are coming in packed. So I'm going to unpack these. And, there we go. We can see that orient now working. So that also may have been affecting. So let's run the sim again with these unpacked. Now I want to set this to pack. It's all fine. But our rotations may be, wow. Well, they're rotating differently. They're not all facing the same direction, which is good. And look, it just looks like he's running through the air. They're flipping wildly, which is crazy. So we can set, you know, some orientation, and the orientation will stop that flipping going on. But you can see all the other ones are also kind of, you know, weirdly oriented. So we might need to do some things for that. We could also spin them, you know, once they're in the air or something, or not use orient as well. We could use rotation, and that is a vector 3. And then we can, let's see, does this work? No, it doesn't seem to. I think we need some other attributes if we want to use rotation. Let's just use orient for now. That'll be fine. I'm going to set this to 0, 0, 0, 1, 1, 1. And we won't worry about these ones in the air. And let's have a look at this now. There we go. So, crazy elephants flying in our tornado. There's probably too many, you know. This is quite the herd. So let's thin this down. Thin the herd. Let's go. Try and get as few as possible without removing them all entirely. And we could get some pop spinning going on, you know, way back when we worked on the Kong project. We looked at that for the leaves, getting that spinning happening. So, I removed all the ones that were in the path of the twister. That was smart. Oh, there we go. We got one little guy spinning. That's right. It's working its way through the plains of Africa. Oh, that's some interesting rotation that's going on there. I guess, yeah, it was because I just basically broke the orient by setting it to dimensions 3. Alright, well let's just ditch the orient, because that seems to be kind of spinning around crazily, which is maybe fine. There we go. So we got one little elephant flying around. Now, it probably, you know, may be better to try and run this as a simulation. You would certainly get some more interesting behavior. So if I put this into a rigid body solver, what is it, RBD solver, so the SOP, I'm going to do the SOP-based one. These are packed coming in here. Make sure they're not through the ground plane. They're not, or almost. They kind of are. So I'm going to put a ground plane. And I'm going to dive inside here, and I'm going to use pop advect by volumes. And I'm going to grab my Pyro Solver result. So this is generating a velocity field. If I just put a null down here and say out tornado vels in my RBD bullet solver, point that to, whoops, how far do I have to go up? There we go. Out tornado vels. This is going to take those velocities and hopefully move those around. So let's see what happens. There's going to be gravity on here, and these are probably just going to fall over like they're rigid things. So it looks like they're all resting on their feet, which is kind of funny. And let's see if it ever gets picked up. Doesn't look like it. So I think they're all maybe going to sleep. Let me just check the bullet solver. Sleep time, I'm going to set that to 0. See if that helps. You can see they're all kind of rocking a bit more. Oh, look at that guy. He's gone to sleep. He's had enough. So we could make these dynamic as well, like have them actually be walking until the point that they get sucked up. Here we go. The cool thing is too, if these leave the velocity field, they will fall back down. And yeah, that's right. They will fall back down because there's gravity. And this is going to like pick them up and fling them around. So this would be something that I would do for destruction as well. So even though this is, you know, very silly, it is still a very good technique to look at because it is what we would do if we were destroying a house as well. So we can turn on the guide as well, just so it's easier to see, because it's a little bit hard to tell where the actual velocity field is. So I've just added more elephants in now, and now we should see, hopefully we'll see a couple of other ones get sucked up. So you can see as this approaches, sort of starting to pull them in. There we go, this one's getting sucked in. And up he goes. Oh, look at that. Great. Hey, Zoe. Zoe? Yeah. How's it going? Good, thank you. I'm great. Just picking up some elephants with a tornado. Just your average day working in Houdini. So we're not really getting any that are sucking right up the top with this method. Probably we just need to play around with maybe the popped vect. We've got air resistance here, just like we did on the pop curve force. So the more we increase this, the more we'll get those hopefully following. So let's have a look at that. And we've got other things to, you know, deal with, like friction, and you can see now, look at this guy. He's getting carried up there. I'm getting a lot more, wow, crazy. I'm getting a lot more kind of motion. And off he goes. Looks like he's caught in a little air pocket there. Again, we might need to set up some conditions for, you know, for how this stuff is behaving when it's outside of that volume as well. Because you can see these actually fall down really slowly. And I think it would, you know, probably be better if they were falling a lot faster. Scale of this scene is quite large as well, so we could just increase the gravity value. But it's usually a good idea to put conditions down. Uh-oh. Please don't crash. That freeze reminded me that I need to save, because it would be a tragedy to lose this masterpiece. So what am I going to call this? Tornado elephant bonanza. Please don't crash. That moment when everything freezes and your heart skips a beat. Houdini, it's annoying. You can't turn on autosave and have it be on all the time. Like, you have to turn it on every session, which I find I always forget. Hey Zoe, so what have you been doing in Houdini? Let me know. Yeah. Oh, crashing when you're like trying to save is the worst. Or you click save and then it crashes. It's just awful. Why would it do that? Houdini's pretty good. I mean, it does crash when you really force it. It can crash. When you really push the memory limits or do something silly like put a crazy value in volume creation or something, then it can crash. But it's, you know, it's mostly pretty stable. Always keep an eye on things like memory limit, just to make sure. Whoa. Alright, so anyway, I mean, you get the idea of this. It's kind of, I think it's working pretty well. We're getting some nicer motion out of it, which is cool. So, you can kind of see, you know, you get that kind of tumbling and like this. This is really cool what happens with this guy here. I don't know what's going on there. There's two elephants in an embrace. Looks like they've been created on top of each other. I guess that's the problem. There we go. So yeah, I think, you know, you probably need stronger gravity because they're just falling a little slowly when they're outside of that. Or maybe some other condition as well. Doesn't, yeah, Mitchell. Hey Mitchell, how's it going? Doesn't crash nearly as much as Maya. That's right. I mean, back when I used to use 3D Studio Max, like we would just have tallies on a whiteboard of how many times you would crash because it was just ridiculous. Like, I think I had 100 crashes in a day working on some file, and it's just like, yeah. It's like, why can't they fix these problems? And that's why, you know, so many people as well enjoyed switching over to Houdini, because it just wasn't like that. Yeah, it's ridiculous. Max was very, very buggy, and they kept promising that they would rewrite it and change it, but they were just empty promises. They never did. They're still, you know, kind of just tacking fixes on, and a bit of sticky tape here and duct tape there, bit of glue. Hopefully it holds together. But man, yeah. Crashes in Max and Maya as well, but yeah, Max was awful for that. It may have just been, you know, part of it was like we're always trying to push things, do things that you know, maybe the computer couldn't handle as well. But yeah, it was certainly the software. So I don't know what I'm doing with this. I think this is fine. You know, we can do some more with it. Let's have a look at the Pyro Sim again. I think the Pyro Sim, let's go to the Shape tab, Dissipation, I'm gonna take down. And, wow, you can see when I do that it shows up a lot of issues, I guess, with the Pyro Sim, is that, you know, it's very smooth. We don't have a lot of detail. So let's add some disturbance. I'm just gonna crank it up to 10. Default's 0.15, but, you know, it's usually pretty low. And I just want to see something. So I usually crank it up pretty high. Also check, like, what the block size is and what the control field is doing. So the control field is useful. What is a good thing to do with this Pyro Solver here? Under simulation, turn on calculate speed field. And it will actually create a field that you can use in your disturbance or other effectors. So I can put speed in here. And what this is going to do is when the pyro is moving quickly, it's going to add more disturbance because this acts as a multiplier. So it's got a control range here. So at the moment, it's only sampling the speed between 0 and 1. So when the speed is 0, when stuff isn't moving, it's going to do less or no disturbance, and less and less and less, and then it gets greater and greater and greater as the speed approaches 1. So you might need to change these ranges, but it's a really good way of adding disturbance only to fast moving sections. So that we can add a ton of disturbance, and then as this stuff slows down, as it sort of leaves that velocity area, it'll get less and less. So it creates a really nice kind of fall off of noise. It's really good for explosions as well. You get that big burst of energy at the start. You want a lot of noise breaking things up. But then as it slows down, you don't want it to continually just add noise because it ends up being just a fluffy mess. So this speed field is a really good way of kind of controlling that and not ending up with that super blurry, fluffy result. So it's maybe a little quick. The disturbance is pushing, it is affecting the velocity, so it's a force that's going to be pushing that stuff, so it may be a little bit fast. I don't know, but let's get going. See, I might just disconnect the elephants for now. So yeah, this is probably a little too intense, but you can see, you know, it's starting to kind of come together in terms of there's a lot of cool stuff going on. This disturbance is intense. It's really crazy and it's a bit fast, but there's a lot of cool shapes going on now. And when you look at it as a volume as well, it's really kind of cool. Let's look at it from Tommy's perspective. And I think he would be terrified. Let's maybe we'll pull Tommy back a little bit, or create a second Tommy, and just maybe move him. No gizmo. Move him back like that. Tommy's not having a good day, that's right. Poor Tommy. So we could kind of create a camera like this. We go new camera, and then go to the view and play around with the focal length and aperture to get nice kind of widescreen, wide field of view camera. Change the clipping so I can zoom right in. Now we can get some sense of scale. And, you know, when you do that, it helps to evaluate speed and things like that as well. So if I flip book and then let's go, yeah, we'll just do a flip book, see what happens. Hopefully it doesn't crash. Then we can evaluate speed a little better as well, because the viewport's always not really real time. So obviously this is just insane in terms of the speed. It's just way too much. Although, you know, some tornadoes are pretty fast moving. We don't have a ground plane in our Pyro as well, so we probably want to do that. Let's have a look. So yeah, way too fast, I think. And we're also kind of losing a lot of the sense of the tornado. So we might want to try and just wind those things back a little bit. Although once it kind of gets going, you start to get that again. You start to see that more. So let's have a look. Look at all our different elements. We've got our original source here, so we could just kind of assess what that was doing as well. Yeah, so our Pyro just needs to be toned down. Let's go, what am I going to do? Change my sourcing. I could turn my velocity down off my source, but I think disturbance, let's take that down to 15 maybe. Simulation, you can always change the timescale as well and just turn the timescale down and see what kind of happens there. I don't have any temperature, so there's no buoyancy being calculated at the moment. So all this stuff is kind of not really being used. Shredding, turbulence. Yeah, it's all good. Let's just go look. I'll increase the density as well. Yeah, so maybe our block size actually is, let's see. Let's turn that off, just get a baseline. I think it's maybe our velocities that are pushing stuff out a little much. So let's just set that. Instead of add, I'm going to set that to pull. And I'll do, same as the temperature here is set to pull. What this does is it's a lot less of a kind of impulse effect, and it's more of a, as it describes, a pulling effect. So it doesn't sort of just put all of the velocity out there every frame. It actually kind of accumulates up to that value, which is what this acceleration is. It's an acceleration up to the value that you're bringing in. And you can see it's no longer throwing stuff out a lot. It's kind of an interesting sort of trailing effect instead. And you can play with this. So, you know, you can increase that acceleration. So we could just kind of play with that more and more. The other thing that we could do is to create a separate velocity field. So we've got this one here, which is generating this. And within this is our velocity. These blocks that we're seeing here is the velocity field, but it's very tight to this effect. So maybe we want to actually have an additional velocity field. So we'll just rasterize V by itself and have the scale of that be a lot broader. So it kind of affects more in a broader way rather than being really tight to where that source core is. That might be interesting. So let's try that. So I'm just rasterizing V here. I'm gonna actually call this like something different. Maybe tornado V. That doesn't really matter. Tornado underscore V. And I need to just rename V here. So V at V. Oh, actually V at tornado underscore V equals V at V. What this is doing is just basically we've got V in here as well. If we want to use that original one as well as this tornado V, we need to kind of separate them somehow. So by renaming or just copying the value of V into this new attribute called tornado V, which we also rasterize. Now if we merge these back together, we can just reference that in the source. So we can just say, in here we could just duplicate or create another one here. Field rank is vector because it's a velocity. Source volume is tornado V. And the target field is vel. So it's always going to end up in vel. But now we could have like, this is our original one here. So we could have that set to add, for example. Let's just turn that off for now. But this one we could have set to pull. And we could control that somehow. So it gives you the option of having two different types of velocity. And this tornado one is a lot broader. Let's look at our Pyro Solver. Is a lot broader and it's going to have a more kind of, yeah, hopefully overall sort of effect. And be less tight to where that core is. So let's see. So here's our core there. So we can also crank this up, so you can crank the scale as well as the acceleration strength, and that will make it stronger. I think maybe cranking the scale possibly is not a great idea. But you can see it's definitely sort of behaving a lot slower now, and if you look through the camera, hopefully it just feels a bit more large scale as well. I've turned disturbance off for the time being just to kind of nail these velocities down. But hopefully it just, you know, feels a bit more large scale by slowing all these things down and not having like really fast moving impulses. It just helps it feel bigger. So I might turn this one back on. Or maybe just set it to 0.5. I'll leave it on add for now and see kind of what that gives us. You still want to get that sense of swirling, so we don't want to lose that. the other thing that we could add in here as well, we could try, don't know if we need it, but we could also add in a gas curve force, which is kind of similar to the pop curve force, but obviously it's a gas one. It works with Pyro. And that might give us some interesting behavior as well. So we could try adding that in too. This is super low res at the moment as well, so it's kind of, you know, it's not that easy to judge some of the details. It's interesting what's happening here. It's less kind of swirling around the core and more trailing, which I guess is due to our pull. Let's set this to add and see what this one does set to add. Wow, look at that. Crazy mushroom clouds. So you can see like a massive difference between add and pull. Turn that down. Let's just go 0.2. I'll turn this one off for now, just so we can kind of thank you, Audrey. Yeah, I think, yeah. Don't be Akron. It's nothing worse than Akron. So yeah, look, there's some interesting things happening here. I think let's just turn it down even more. See, like with all this stuff, it just, you know, it just takes a bit of practice and a bit of dialing in. Like I don't know, you know, these settings are always different for whatever effect you do. So there's no like, cool, I'll just put in 0.1 and it'll be fine. It's all relative to what the original speed of the thing was that I was generating this velocity field, or scale of the effect, you know, how fast it's moving. It's just, there's so many variables that you do just need to play with this stuff a lot to kind of work that out and figure those things out. There we go, we're getting a bit more kind of swirling and seeing that a little more. It's still a bit kind of bulbous and buoyant. Maybe, you know, maybe the dissipation we could take up a little bit. Maybe I'll turn the disturbance on now. A drag sometimes helps as well, like adding a little bit of drag sometimes helps. I don't think there's an option for that here. I'm going to turn on close below. That'll create a ground plane for us. There's no drag option here, but we could add a gas damp in here. This is very aggressive, this gas damp, so I usually just set it super low. And whenever you are trying to get a certain behavior with particles or whatever it might be, adding a drag, just like the air resistance value in the pop curve force, adding a drag just helps it. Like if you've got really fast impulses of velocity, adding the drag in there just helps tame everything down and makes it follow better. So it's always handy when you're trying to get something to follow something or stick to a particular shape. Adding a drag in there will just help calm everything down. And you can see that has kind of tamed that stuff a little bit. So there's some interesting things going on there. We've got this ground in there as well now. And our original source as well, you know, we're cutting out some of those points, so we can adjust this to be, you know, a bit different. Take that threshold down a little bit. I think it must be this section that's kind of compressing some of those particles in there. I don't know which part that is. Must be here. We can change our search radius here as well. It doesn't really seem to be affecting it. So the other thing we could do here is actually measure like the distance. So we've got, if we have a look at this, so here's our position here. That's our line position of all the points on that line. And we've got our original position. So to add an extra control here, because these ones out here, I kind of don't really like the way they're getting sucked in. To add an extra control, what I can do is measure the distance between these two, so the positions of the points like this, and the positions of the points compressed into the line. And that, if I output that into color, maybe I need to run it through a fit, because we've got quite large values, large ranges here. Maybe if I set that between 0 and 100, maybe what, 50, 25, you can see that the points that are furthest away from the line over here are getting this white value. So I can kind of take this down, yeah, maybe 15, 20. And I could also use this as a way to restrict in my bias what is blending. So we've got the ramp that's controlling it as well, but we could use this distance as a multiplier on the ramp as well, so that if we multiply after the ramp with this fit, probably need to invert it and change as I change this value here. So what you'll see is as I increase this, the ones that are close get sucked in or get affected by this ramp position, but you can see these ones out here are no longer being affected because they're, when it's at a distance of 10 or greater, it's getting set to 0. So you can see that happening there. So it's just like an extra distance control. So you can see values that are 5 and greater are now getting set to 0, so that we don't get all of the ones that are far away from the curve, only the ones that are really close get sucked in. So we can, yeah, we can adjust it. You could run that through a ramp as well if you wanted to create some sort of, you know, fall-off, custom fall-off. But now we're not getting those bits getting kind of weirdly sucked in, compressed like that when they're really far away. Alright, so that hopefully will help with our sourcing and with our overall effect. You can see now we're getting this nice kind of fall-off on the ground there. Okie dokie. So what else are we going to do? Here too, you know, the way that we're removing these is based on speed, but we could also do it based on like a radius around the curve. So again, we could do that based on distance, but we could also do it like based on, yeah, based on transferring color from the curve, for instance. That could work. But I think what we've got so far is fine. So let's run this. Let's see. We've only got 15 minutes or so left, so let's just try and see what this is looking like. I might try and go slightly higher resolution and see if that helps. I did crank the density on the look tab as well, so this is displaying quite thick. Let's go Tommy Cam. Alright, so there's some cool kind of swirling going on there, I think. You know, it's starting to get there. Do we have disturbance on? We've got disturbance on. It's probably, maybe we could add some more disturbances in there. Or adjust our block size or control field as well. The control range might be useful to adjust that. So I don't even know if we need our core now. Probably don't really see a lot of it. Might serve to just thicken it up when we do rendering, but you don't really see a lot of it now because of the way the pyro is working. So I think that's quite good. Let's add a little bit more disturbance. Take the block size down a little bit. Just crank that up a tiny bit. And you can add multiple disturbances as well. And usually that's what I'll do, is I'll have like a large scale disturbance to do broad shapes, and then medium scale maybe, and then a small scale. And they might all use different settings and different control fields to apply those excuse me, to apply those noises to different areas. So with this, you're kind of limited, just with this one on the outside. But if you double click, it'll take you to that force input, and you can add other ones in there as well. So let's have a look at that. Yeah, not too bad. So yeah, if we go in here where we put this gas damp, we can add a gas disturbance. Gas disturb. Merge it together. Whoops. Merge. And then this one has all the same kind of settings as more, so it looks a little bit different, but you can put speed in there again. And turn off that threshold range and just set the strength. You got different types here. We'll set it to block base so it's the same. But here the block size we could do like 0.1 for example. Set the strength to be high. You've also got an independent timescale here, so if you are doing timescale changes on your solver, it's a good idea to link those up so that you don't have like a different timescale on your other nodes that are inside. These ones that are already set up in the Pyro Solver are already hooked up to that, but if you create your own, you kind of need to do that yourself. It's not always an issue. I didn't have it on the gas damp and it's fine, but yeah, sometimes it can create an issue, especially if you've got crazy timescales or changing timescales. You don't want to have like your timescale at 0.5 and then a disturbance running at 1, because it'll be disturbing much more quickly than the timescale of everything else, and it might look a bit weird. So now we've got another disturbance in there. So let's change the range. So this one, maybe we'll do like when it's only between, I don't know, 0 and 0. Let's do actually 0 to 3 instead. So one thing we could do here with these different ones is we could have in our speed, we could have one that applies when the speed is really high. So like 3 to 5, for example, we could have, yeah, maybe a block size of 0.25, but it's really strong. And then, so when the speed is 3, it's not going to be applying it, but when it's over 3 and between 3 and 5, it's going to be ramping up to be full on. So it's like only applied when things are moving really quick. And then this one would be, more so when things are moving slower and starting to slow down. So you can experiment with, with different kind of disturbances set to work on different aspects of the simulation and different speeds, and it gives you a really nice kind of complex shaping behavior rather than just disturbing everything or using one disturbance with a single control field. So let's just finally do a save and up the voxel size a little bit. Let's go 0.1, why not, just for fun. It's always a bit deceiving looking at stuff in the viewport though, because the viewport does downsample your volume, so you're never gonna see perfect one-to-one detail until you render it. But you can see at 0.1, I'm starting to see a lot more details, which is cool. Seeing a lot of that fine disturbance that I just put in. So you can certainly see it to a point, but then once you start to go really high res, there's a point where it doesn't get any better because of the downsampling that happens in the viewport. You can turn it off, but it's not a good idea because your graphics card just will tank. So I always, do a render test as well, just to see kind of what things are looking like. So there's a lot more details going on there. Tommy's not happy. Let's go Tommy 2 cam right in the action. So we could, this has a shader, shot material path, coming out of these wrapped up Pyro Solvers, so we could just chuck our view flag on there. We've got a spotlight. Let's go render view, render camera 2, hit save, hit render. and see what it looks like. Spotlight is not going to take too long, especially it's just, you know, it's just smoke. There's nothing else really going on. So Spotlight's pretty quick to render volumes. It's pretty noisy, so let's just go to our out context. I'm going to change this to PBR, and I'm going to set the stochastic samples to, let's go 16. And you can see that that smooths it out. But the speed is not that bad. So let's have a look at our look tab on the Pyro Solver here, because that controls the shader as well. So if we increase the density there, we'll see that change in the render. You can see it's pretty low res still. If I middle click here and see, it's only 3 million voxels, so it's very low resolution, and that's why it looks so blocky and awful. But if I go back to camera 1 instead, which is much further away, you know, this voxel size of 0.1 might be fine. So it depends how close we get. If it's a really far away shot, something really big, you can kind of see that that blockiness, it's still there, so you probably do want to go a little higher res, but it becomes less of an issue. So that's always something to consider when you're working on these things. So yeah, I mean, maybe the disturbance is a little crazy. It's a little bit too kind of noisy, getting a little bit too fluffy. But I think this tornado starts to look its best, like much further on. Let me just, one thing when you're using this interactive renderer, make sure you turn it off. Otherwise, it's just going to keep trying to render every frame that this simulation is cooking. And yeah, we're almost out of time, so I'll just let this run, and hopefully, you know, hopefully we can turn this into something cool next week as well. I'll try and find some other assets that aren't elephants, and see if we can do a little destruction or something. We can set up a little scene, and maybe, you know, turn this into something, you know, something interesting. I think, yeah, I don't know, like this big cloud that's kind of forming and being left behind. I think something needs to be done with it. I don't really know what. Maybe there needs to be just zoom out so far. Yeah, that's right. Perfect. Maybe this stuff just needs an overall swirling. So maybe we need to add like a vortex field in there as well, just to get like some swirling as these are rotating off and peeling off the main simulation. Maybe we just need this overall kind of swirling vortex, and that, you know, that might just help it feel a bit more part of the tornado. That's right. Look, there we go. It's perfect. So, well, we could, you know, we could do that. We could merge it in here. We could just create like a, what am I going to do? What am I going to do? I mean, I could use these velocities again, these particle velocities, because they are spiraling. But if we have a look at the volume velocity, we do have vortex, add vortex. So if I was to create like a, where's our original grid? Here's our original grid. Oh, actually, yeah, we want it to be based on our curve location. So what I'll do is I'll do a, create an attribute angle. I'll say v at v equals 1. Actually, 0, 1, 0. Like that. And plug that into the resample maybe. I'm going to volume rasterize that. Okay, so that should give me something. There we go, it's got a V field there. Volume velocity, so V doesn't really show up terribly well in the viewport, so you create it like a volume trail. velocity volumes, points to trail. I could just do something like this, points from volume. Whoa, points from volume. Just take a bound of my line, run a points from volume through it, up the point separation, run that into the volume trail. Oh, there we go. I can see my velocities now as like little lines. So the coming out of here, it's just saying velocities up. So they're all pointing up. But on this, if I turn on the vortex, okay. So it doesn't even matter that I plugged in my line here. It's actually taking this. You can see that vortex there. It's based on the center of our. You can see this kind of moving around it. So the vortex is not moving. So we actually need to add values in here. So we need to reference like the point position, I think, of all the way back up here. We've got our points. Even way back up here, we've got our points. Oh, probably, yeah, we could do it. Maybe based on this one here. So that's 0.0. So if I just go like, maybe here I'll create a null and I'll say outline. In this volume velocity here, what I could do with the center is use a point expression to grab that position. So point and path that to outline. And then the next thing we need is the point number, so it's 0.0. And then we need the attribute. So the attribute is P. And then the final thing is the index. Because this is a vector, it's got 3 indexes, 0, 1, and 2. And the first index is X, which is 0. And this will now grab that X position from 0.0. So copy that, paste it in each channel, change the index, so 1 for Y and 2 for Z. And now what we should see, if we look at this through the volume trail, is that the center of our vortex should always be where that 0.1 is. There we go, we can see it there, or that 0.0. But I think what we need to do, instead of generating it from the bounds, or generating it from the curve itself, we should just do it like maybe based on the bounds of the curve. And then instead of rasterizing, we could do points from volume, I guess. And just copy that wrangle there, plug that into the points from volume to set a velocity, rasterize that into a volume, and there's our vortex. Let's see how it moves. So it's actually kind of moving weirdly, not what I expected. Let's see, is this bound sticking to where our curve is? Where's our curve? There. So I think this needs to be actually based on like the position of 0.0. So what am I going to do? I'm going to blast up here from my outline. I'm going to blast everything but 0.0. Points, delete non-selected, then I should get, there's my 0.0. Ooh, my time shift. Right. So, copy my time shift out of there and put it before the null. I think that's probably why it was so different. Let's have a look. But still, we need this bound to be much larger. So let's go like 2, 4. Whoa, too much. 4, 4, 4. Hopefully then we can see that center of that. There we go. So we probably need it to be larger again, but now we can see that center is moving. I don't know, I probably didn't make a lot of sense to people, but hopefully it made some sense. But there you go, you can see like there's our 0.1 right at the bottom there. You can see from the top view that vortex center now is just following that position. So yeah, I think instead of generating it from the curve, what I'm going to do is generate this from this point position. I'm just going to maybe even just copy a sphere to that location So use a copy to points. Target points to copy to, copy a sphere. That's just going to copy it to the base as well, which is kind of cool. And then I'll do my points from volume on that. And then I get this like vortex ball, which is following the base. And I can control the size of that. And then on here, I think I can control things like the vortex radius. So I can make that bigger and have fall off as well, which is kind of cool. So then now I've got that. I've got another V field here. I might just rename that similarly to what I did here, but I'm going to do it a different way. I'm going to use a name sop and rename V to being vortex vel. And then again, I can merge that in with my Pyro Solver. And, oops, don't go in there. Just go to my source tab and add in another velocity field. Vector, what did I call it? Vortex vel. Going into vel and add again, or pull, or you know, whatever you want to do there. But that way now I'll have like an extra kind of swirling field that I can control the scale of. That can be a lot broader than my original kind of particle sim. So there's my original particle sim, and here's the scale of my vortex that's surrounding that. So I can kind of crank that up if I want to. Or maybe not too much. You got to watch the resolution as well. So this might be 35 million. So let's just take that down. So, you know, something like that might be useful. I don't know. Maybe that's too big. But just to try and get some more swirling in there and keep that stuff moving as it comes off the main spiral. It might help. Who knows? You have to test. I mean, you may just need to set these values up a lot as well. Like really crank this stuff to see it. Oh, there you go. You can see now. If I set that to 10, you can see that. You can see that vortex happening now. So it's definitely working. But I think just having it as like a subtle thing will kind of just help all that stuff that's sort of just hanging around in the air. Yeah, to kind of keep moving around in that rotation. Just might add a bit more of that rotational effect, especially if you keep it low so it's not like super high in the air as well, just keeping all that low stuff moving. Anyway, yeah, there you go. We are out of time, so we'll have to continue this next week. Hopefully my vortex actually is going the right direction. I didn't check that. Could be the wrong way, which wouldn't be good. But yeah, we'll continue working on this next week. I'll do some more. I'll probably write this out to disk, and we can have a look and see what it looks like next week at a higher resolution. Back to work. Me too. No more tornado fun for me. And yeah, we'll keep going. We'll maybe start looking at doing some destruction, or start doing some additional elements like particles, debris, maybe some additional pyro elements as well. I find that with this stuff, you know, it's a lot of different layers. So this is just kind of trying to come up with the main funnel, I guess. And then there's a whole lot of extra elements that we're going to need to add in. So I hope you guys enjoyed it. I'll see you guys next week. Hit the like and subscribe button if you haven't already, and thank you to everyone that joins me every week. I really appreciate it. No worries. Thanks, Audrey. Thanks for joining me. See you guys next week. Bye.